This video discusses on the history of the Molde and the concept of mole. Before going to the history of Molde, let's understand some basic idea about physical quantities. A physical quantity is a property of a material or system that can be measured and quantified. It can be expressed as a value which is the product of numeric value and a unit of measurement. For example, mass can be quantified as m is equal to n kg, where n is the numeric value and kg is the unit symbol. For example, 1 kilogram of apple, 2 kilogram of apple, where 1 and 2 denote the numeric value and kg represents the unit. Physical quantities again classified into fundamental quantity and derived quantity. The physical quantities which don't depend on any other physical quantities for their measurement are known as fundamental quantities. There are 7 fundamental quantities in physics. One is length, its unit is meter; mass, its unit is kilogram; time, its unit is second; electric current, its unit is ampere; thermodynamic temperature, its unit is Kelvin; luminous intensity, its unit is candela; and amount of substance, its unit is mole. Now let's move to the concept of mole. We are able to count the materials which are in macroscopic level. For example, we can count the number of people inside this bus and also students who are standing in this assembly. But in microscopic level, it is not possible to count the number of atoms, molecules in this given sample. So, counting of atoms, molecule is standardized through the concept of mole. So, 1 mole is defined as 6.022 into 10 raised to 23 particles or atom or molecule. For example, 1 mole of gold contains 6.022 into 10 raised to 23 atom, and 1 mole of water contains 6.022 into 10 raised to 23 water molecules. And 1 mole of carbon-12 isotope contains 6.022 into 10 raised to 23 atoms. In chemistry, 1 mole is defined as the number of atoms in exactly 12 grams of pure carbon-12 isotope. In other words, number of particles in 1 mole is equal to the number of atoms in the 12 gram of carbon-12 isotope. In these samples, zinc, carbon, magnesium, copper, sulfur, silicon, lead, tin exist in atomic form, that is, there is no bond between the individual atom. So, these samples contain 6.022 into 10 raised to 23 atom. Here, their masses are different, but the number of atoms in each sample is same. The Italian physicist Lorenzo Romano Amedeo Carlo Avogadro is credited with discovering the Avogadro's number, so 6.022 into 10 raised to 23 is also known as Avogadro's constant.